Hi everybody, this is Mr. Crowther, and I'm going to be going over exponential growth and decay word problems for you. So this is the first of three part videos. I'm trying to keep them short, under 10 minutes, so you can take your time and go through. Don't hesitate to reach out to myself or your Algebra 1 teacher. We're all working together and planning these lessons and getting these remote learning videos up for you. So keeping that in mind, we are going to start by looking at an exponential word problem. So the world population in the year 2000 was approximately 6.08 billion people. The annual rate of increase was about 1.26%. The first thing we are asked is to find the growth factor of the world population. So they've done us a little bit of a favor and let us know that it is a growth factor, which means that our B value is going to be greater than 1. So in order to get the growth factor, I need to find the growth rate. Now, if you remember, the B value is my growth factor, and that is equivalent to 1 plus the rate. The rate comes from my percentage. So I have to convert 1.26% into a decimal, and I do that by moving the decimal place 2 places to the left or dividing by 100. So in this case, I would get 0.0126. That is what my rate is. So to figure out my growth factor, I'm going to do 1 plus 0.0126 to get my growth factor of 1.0126. That is my growth factor. That is my B value. Keeping in mind that we're using the exponential formula, y equals a times b to the power of x. So now that we found our b value, we have enough information to write a function model for the world population. If you remember, our a value is our starting amount, so y equals, and in this problem, it is 6.08 billion. It is perfectly fine to use 6.08 as your starting amount. We just need to remember at the end, we're referring to billions of people. You can, if you want to, change this into 608000000, but that is going to make it a little more complex for you as you write these things out. So if we can abbreviate it to 6.08 billion, that'll help us in the long run. So that again is my A value. My B value is what we got with my growth factor in part A, 1.0126. And as this is just a model, my exponent is x. So that is the model that allowed me to predict the world population at any point in time. However, for this, we want this to be a specific point in time in the year 2020. So the key part of this is that x is the number of years past 2000. So if we're in 2020, and I want the number of years past 2000, I'm going to subtract 2000 to get 20. And that is my x value. So that will be my exponent. So if I scroll up, and remember that's the formula I'm using. So y equals 6.08 times 1.0126. And this time, instead of x, I'm going to put in 20 as my exponent. So now comes the time when you're going to need to get your calculators out. And depending on your calculator, your input's going to be slightly different. So I'm just going to use the one that comes with this computer, the Windows calculator. And I'm going to do 1.0126. And to raise it to the 20th power, I have to use the x to the y button. And from viewing some of my students' calculators, I know this is a button they have on some of theirs. So I'm going to use that to the 20th power. And I get 1.28457 on a whole bunch of other numbers. I need to remember that I need to multiply that by the 6.08 billion. So the 6.08, so times 6.08 gives me a final number of 7.81. And I need to remember that in the context of this problem, we are talking about billions of people. So my solution was 7.81. And I need to remember that it is billion people. So hopefully that's a quick refresher on exponential growth. The next video will take us into an exponential decay problem. And part 3 deals with exponents within tables.